We're going. All right. So I know all of you remember how to simplify a fraction, but the directions say to simplify the numerical fraction 18 over 12 by first expressing it as a product of two fractions, one of which is equal to 1. So here's what that means. I could write this as 18 is the same thing as 2 times what? 9. And 12 is the same thing as 2 times what? 6. I could also write it as 3 times what is 18? And 3 times what is 12? I could also write it as 6 times what is 18? And 6 times what is 12? The whole concept is that you see that when you divide both the numerator and the denominator by 2, that's no different than multiplying by 1. When you divide the numerator and the denominator by 3, it's 1. When you divide by 6, it's 1. I put your packet on your desk with your name on it. I wrote everyone's names on their packet in pen. Zach Miller, I'm going to give you the very last packet that I have, but what's going to be really funny is that when it's time to go, you're going to find your packet with your name on it, and you're going to give it to me. Okay?
Thank you.
You're so welcome. Okay. So, what does 18 over 12 reduce to? Reduces to 3 over 2. Reduces to 3 over 2. So now we're going to look at this, and we're going to do the same thing. We're going to try to break it up into factors that are the same both in the numerator and the denominator. So tell me about x squared minus 9. What kind of quadratic is this? It is a binomial. It's a special one when we factor it. Difference of 2 squares. Good job. So how do we factor that? You have to take the square root. What's the square root of x squared? And what's the square root of 9? So it factors out to be x plus 3 and x minus 3. This was one of those special ones that we did that I think Manuel did all of the special ones, all of the difference of squares on that activity that we did last. Was that on Monday or Tuesday? Manuel, weren't those the ones that you did all of them on? You tried to do difference of squares on all of them. He was trying to like hog that. Okay. What about the bottom number? How can I simplify 2x plus 6? Does it have a G, C, F? Yeah, what is it? I can take a 2 out. So when I take a 2 out, I'm left with x plus 3. Do you see any term or factor in the numerator that's exactly the same as the denominator? What? So we can cancel those out. So when I simplify this, I'm left with x minus 3 divided by 2. How do we feel about that? Good? Okay. Let's go to the next one. You see I put a filled out copy on your desk. Okay, that's fine. All right. So in example 2, I want to remind you of rules that you learned in Math 1, but should have been in like 8th grade exponent rules, right? So when you're multiplying powers with the same base, what do you actually do to the exponents? You add them. Okay, so I'm going to do something that's a little bit crazy, and I'm going to break up the numerator. 3 is prime. I can't break that up at all. x to the 5th, I'm going to leave exactly like that. But y to the 6th, I see I have a y cubed down below. So I'm going to write y to the 6th as y cubed times y cubed. Because 3 plus 3 is 6, right? And then for the denominator, 6, well, that's the same thing as 3 times what? 2. And x to the 8th, well, that's the same thing as x to the 5th times x cubed, right? Because 5 plus 3 is 8 times y cubed. I don't ever really try to make them look identical, but I'm doing this for you, I think, just to get you started. So what are the factors that are exactly the same in the numerator and in the denominator? I have a 3, I have a y to the 3rd, and an x to the 5th. So when I cross those off, what do I have left over? Numerator is y cubed over 2x cubed. So for example B, I'm going to do example B a little bit differently. I'm going to focus on the constants first. So I have 20 divided by 4 times x to the 10th divided by x squared times y to the 8th over 1. So I'm trying to group them by their either constant or same variable term, just so you can see a different way to do it. So what's 20 divided by 4? 5. What's the rule? If the base is the same and I'm dividing, I do what with the exponents? Subtract. So 10 minus 2 is x to the 8th. And y to the 8th, we're not doing anything to it, so you just multiply it right along. All right. Does that make sense? So how do you want to look at C? Do you want me to do C the same way that A was done or the same way that B was done? A? Okay. So example C. I'm not doing anything with the numerator. 7x cubed y. Now let's focus on our denominator. 21, guys, shut it, or Michael, I'm going to make you come sit over here by me. 21 is the same thing as what times 7? 3 times 7. So 3 times 7. X to the 5th power is the same thing as what? And I want it to have an x cubed in it. So x cubed times x squared, because 2 plus 3 is 5. And y to the 8th power is the same thing as what? And I want it to have a y to the 1st power in it. Yeah, y times y to the 7th. Good job. So let's see. I have a 7 in the numerator and in the denominator. I have an x cubed in the numerator and in the denominator. I have a y in the numerator and in the denominator. What do I have left? Dun, dun, dun. What's in the numerator? 1. Who said that? 1, right? 7 divided by 7 is 1. X cubed divided by x cubed is 1. Sometimes I don't know why, but you guys want to put a 0 up there. You just want to just forget it. No more numerator. Everything that's in the denominator is now a whole number. So remember that when you cancel everything out of the numerator, it still contains a 1. So we have 1 over 3x squared y to the 7th. Okay. Do we see that? Yes, no, maybe so?
Yes.
Okay, can we go into the next one? It's 1 over, yeah. Okay. So let's look at, Max, are you with me? Okay. So how do you guys want to do number 3? The same way we did A? Okay. So 10 is the same thing as 5 times 2. X to the 6 has to be written as a power of x squared, like a product with x squared. So that's going to be x squared times what? X to the 4th. Y cubed is the smallest y power, so we're going to leave it alone. Now I'm going to go to the denominator. 15 is the same thing as 5 times what? 5 times 3. X squared doesn't change. But y to the 6 is going to be what? Y to the 3rd times y to the 3rd. So when we cancel out, let's see, my 5s cancel out, my x squareds cancel out, and my y cubes cancel out. So I'm left with in the numerator over, perfect. What's my answer choice? 3. Yeah. No. You're totally fine. You're totally fine. If you can cross reduce, like if you can just reduce, divide everything by 5 and not show all those, that is totally fine. I'm just trying to baby step it. Okay. Are we good with that? Okay, flip flop, turn to the next. Okay. So here's where it gets interesting. I have a quadratic function or a quadratic expression divided by another quadratic expression. I know that this is able to be simplified, but the first thing I have to do is factor it. I have to factor it first. So let's talk about the numerator. What are two numbers that you multiply together to get negative 14 that when you add them, you get 7? Sorry, you get 5. Negative 2 and positive 7. So x minus 2 over x plus 7. Okay. X squared minus 4. That's a difference of 2 squares. How does that factor? Perfect. X plus 2, x minus 2. So I can take a factor of x minus 2 from both the numerator and the denominator. When I simplify this, this becomes x plus 7 over x plus 2. Okay, let's look at example B. This is a difference of 2 squares. This has a GCF. So let's see. What's the square root of 4? So 2x. What's the square root of 1? 1. So I have 2x plus 1 times 2x minus 1. Over, what's my GCF in the denominator? 5. When I divide both terms by 5, I'm left with a 2x minus 1. Cancel out. My final answer, 2x plus 1 over 5. We feel good about that? Okay. Next one. Let's do the slide method. What's 3 times 8? So this is really x squared plus 14x plus 24. So what two numbers can you multiply together to get 24 that when you add them, you get 14? 12 and 2. X plus 12, x plus 2. So I've done the slide part. Now I have to divide. I have to divide both terms by 3. So 12 divided by 3 is 4. So my numerator becomes the factor x plus 4 times 3x plus 2 over, how does my denominator factor? Yeah. Cross off x plus 4, x plus 4. I'm left with 3x plus 2 over x minus 4. Are we okay with that? All right. This next concept is going to make your head spin, but it's super cool. So we're going to just simplify these fractions. Do you guys notice that, like, what do you notice about the numerator and the denominator? They're just flipped. They're opposites, right? I'm taking 9 and negative 6, and then 6 and negative 9. So what is 9 take away 6? What is 6 minus 9? What does that reduce to? Okay. What is 15 minus 3? What's 3 minus 15? What does that reduce to? What is A minus B over B minus A? Well, if A was 15 and B was 3, what would it be? It would be negative 1. So it just, do you guys see that we did think of this as A minus B over B minus A. It simplifies to negative 1. So when you have opposites, it automatically is going to reduce to negative 1. Do we need to think about that for a second? Okay, Nathan, watch. If I had 7 minus 2 over 2 minus 7, what does 7 take away 2? Okay. What does 2 take away 7? Okay. What if I told you that 7 equals A and 2 equals B? I'm just going to write it over here. A minus B over B minus A. But what did it equal? Negative 1. Okay. Okay. That's all right. I want you to ask questions if you don't understand. So let's look at this one. What can we take out of the top, the numerator? I think it's got a GCF. Take out a 2, and what does that leave me with? Okay. What kind of problem is the denominator? Difference of 2 squares, right? So how does that factor? Negative x times negative x is a positive x squared, and you have a negative x squared. Factor it just the way that it's written. What's the square root of 25? What's the square root of x squared? So 5 plus x. Oh, sorry. And 5 minus x. Okay. So what do you notice about this and this? They're opposites, right? What do those simplify to? Negative 1. So this is the same thing as saying times negative 1. So what is 2 times negative 1? And what is 5 plus x? Just 5 plus x. So do we see that answer somewhere? It's 1. Why? Because 5 plus x, Reese, you got to keep your eyes open, is the same thing as x plus 5. So it's answer choice 1. Okay. How are we going to factor this numerator? What 2 numbers can you multiply together to get 9? That when you add them, you get negative 6. Negative 3, negative 3. Who was it who said that? Good job, Kane. X minus 3 times x minus 3. What do you notice in the denominator? There's a GCF. 6 leaves me with what? 3 minus x. Okay. So I have an x minus 3 and I have a 3 minus x. What does that mean? Times negative 1. So I really have negative 1 times x minus 3 over 6. If I were to distribute that, I get negative x, right? plus 3 over 6. We try to never write polynomial expressions with the leading coefficient being negative. So is there a way that I could flip-flop that numerator so that the first term isn't negative? Say again. Yeah, I could just make it 3 minus x over 6. What answer choice is that? 4. Say again. Did you answer it yourself? Okay. All right. So